Any questions or concerns, let me know. As you guys know, your DMR quiz this week is actually mañana, isn't it?
Yes.
I believe so. I believe it is tomorrow. So it's a little bit different than the normal pacing. Do you guys remember why our DMR quiz is tomorrow instead of Thursday?
No idea.
Because on Thursday we're doing a project. So on Thursday, please make sure that you bring a ruler. I'd say like a ruler is going to be the main thing. I've got graph paper for you. Bring a ruler and a pencil. You should be good. Okay, so let's run through the answers here. Number one, did you guys go copy.flop right away?
Yes.
All right, so if you copy.flop, we go 3/8 times 16/5 minus 2/5. And then right off the bat, did you guys do the cross canceling?
Yeah.
I think it's wise to do. So the 16 and the 8 would cancel to be a 2 and a 1. All you're really doing there is you're reducing the fraction before you do any of the multiplying or anything like that. So once you get ready to multiply, you're going to multiply your numerators together and your denominators together. 3 times 2 is 6. 1 times 5 is 5. And 6/5 minus 2/5, we already have that common denominator. What do we get? You guys all get 4/5? Final value? Okay. Any questions? Again, look at what I have. Look at what you have. Decide if there's anything we need to talk about. Any questions, concerns? All right, fantastic. Number 2 says simplify completely. And as always, whenever you're simplifying, you want to look for distributive properties first. Do you see any distributive properties here? What do you see? Not the 5. The negative 5. Yeah, so we're going to distribute the minus sign along with the 5. So that minus 5 gets distributed. So that gives me 10 minus 10x plus 15 plus 6 minus 9x plus 8x squared. Once we've done that, we're looking for like terms. Is there anything that is like the 8x squared? There's not. I don't see anything like the 8x squared. I see some other x's, but in order to be like 8x squared, it's got to be something or other x squared. So I'm going to just copy that down to my answer line right there. Is there anything like the negative 9x?
Yes.
What is it?
Negative 10x.
Negative 10x. When you add those up, you get negative 19x. Good. And then the only 3 terms that are left there, the 10, the 15, and the 6, those are all like terms. They are all constants. So when you add those up, you should get 31. So plus 31 would finish out our final expression. Questions? So in 24 hours-ish, you'll be doing a quiz on that one. You comfortable? I just hope you are. Okay, cool. All right. Mentioned this yesterday. Say it again today. If you look just real, without looking at all the details, if you just looked at this and this, can you understand why someone might think that it's the same thing? But what is the most important difference between those two statements? It's the equal sign, right? There's distribution in both. There's parentheses in both. There's x's in both. There's numbers in both. But the one thing that number 3 has that number 2 doesn't have is an equal sign. And so that's what makes this one very different. It allows us to solve for x. Of course, like I said yesterday, the weird thing about this is to solve, the first thing we have to do is simplify. Yeah, if we're going to be solving, we're going to make sure we're simplified first. So there is a distributive property. What's being distributed here on this one? Negative. Yep, that's right. So this negative sign being distributed gives us 8x minus 3x. What's the next symbol? Plus 4 equals 6x plus 7. Have I simplified everything? Am I ready to start solving? No. I got quite a bit more simplifying to do. What could be simplified down? 8x minus 3x. Yeah, that's 5x. Those are like terms. How about now? Is everything completely simplified? I'm ready to start to get the x by itself?
Yes.
Wrong. Yeah, do you see how there's an x on the left and there's an x on the right? If you were going to start getting the x by itself, wouldn't you have to pick one of them? Which one are you going to? You got to get them together before you try to get them isolated. So I could move the 5x over, or I could move the 6x over. Which one do you guys think would be better?
5x.
Okay, we'll move the 6x. That's the one I heard the most of. I think we could go either way. I honestly think moving the 5x over would be a little bit easier. But we'll go with this. So what is 5x minus 6x? Negative 1x or negative x plus 4 equals 7. And then what step would follow that? Subtracting what? So minus 4 from both sides. And now I must be done, right? Because the x is all by itself. Oh, it's not? What's wrong? Oh, I'm solving for positive x technically, right? That's negative x. How do I get rid of that negative? Yep, divide or multiply technically by negative 1 will get me to x equals negative 3 for a final answer. You can always check that by plugging back in like we've done a fair number of times. I think you'd find that it creates a truth so that it works out. Questions, concerns? Again, 24 hours from right now, there will be a quiz question that looks kind of like that. Are you comfortable? Bless you. Bless you. Okay. Finally then, number 4, listing the domain. I've got 2, negative 2, 4, negative 3, and 7. And I've got a range of negative 8, negative 9, 6, 12, 16. No repeats today, right? Yesterday there were a few repeats in there. Is this relation a function?
Yeah.
It is a function. I agree. Yes, it is. Anybody want to offer up an explanation as to why?
Each input is one output.
Yeah, each input has exactly one output. That would be a pretty good explanation. Again, any questions on 4? Okay, very good. Hey, I want to introduce you guys to a new member of our class. This is Maya over here. She is joining us for the first time, and we're glad you're here. I barely know you. I don't know what else to say other than we're glad you're here. So this is Maya, you guys, and feel free to welcome her. As you guys know, I want you guys to think about something really quick. Can you picture the August 20th version of you? Can you remember back to what you were like on August 20th? And can you think about how much you know now versus the August 20th version of you? And I'm not talking about math necessarily. I'm talking about WebAssign. I'm talking about Edpuzzle. I'm talking about videos, et cetera, right? Besides just the math stuff that we've worked really hard with, there's a lot of like procedural things that you've gotten very good at that Maya has no idea about, right? Can you imagine how she might feel a little intimidated and be like, oh man, I got a huge learning curve. Can you picture that? Yeah. So will you guys be a help to her? I mean, I can only imagine she's going to have a lot of questions, and I'm going to do my best to answer whatever questions you might have. Like, and she's not even on Schoology yet. She'll be on Schoology today sometime. I mean, she has a huge learning curve, and that's just for Algebra 1. And you probably have an English class and a history class, and, right? No? Yes? Other science maybe?
No.
No? Okay. You maybe have other classes, whatever it might be. She had a learning curve in those classes too, right? And so what I would love for you guys to do is like take her in, help her out. Colton, you're sitting right next to her. Faith, you're sitting right next to her. You guys might be some key figures in her life for the next week or so as she tries to get up to speed. Yes? I hope you guys will be helpful. I hope that you'll all be helpful. If you see her in the hall, say, hey, Maya, I can see that you're all here. You're doing okay. Do you have any questions? I mean, I would appreciate that. I'm sure she would too. You guys good? Yeah. If you can put yourself in her shoes, she's got a lot to do, and I'd love to see her get up to speed quickly and easily. Okay, we good? All right, fantastic. Let's get a little work done here today. And we're going to do things just a little differently than we normally do. I've got some class examples here if you guys could flip over. I am ultra curious about this. I have no idea how this is going to go. I am wondering if you guys could try these. I know I haven't taught you how to do these yet. I haven't shown you an intro video. I am just super curious to see if you know how to do these or if you can sort of kind of figure it out. I am definitely going to come alongside you and help you and show you answers and do some explaining in a minute. But I'm just curious to see if you can do these by either knowing it or figuring it out or talking amongst each other.
I think I can do number 1.
Okay, so I want everybody, I don't want you to like throw it up on the board quite yet. We'll get to that in just a second. I want everybody to kind of try it, work together, see if you can come up with something good, and then I'll take suggestions and we'll get it all figured out here in a little bit. Question? No? Question? Some of you are like, I think I got it. Okay. You think you got those? Okay, that's cool. Label it as in like write the equation.
Do you have a stapler?
Oh, do I have a stapler? I thought you said, do I have to label it? I have a stapler.
No, he's party sizing.
I have a good stapler, I think. Yes, sir. Hang on one second. It's not red, but it's good. She has no idea what I'm talking about. It's okay.
What? What's a red face?
Give me 1 second because I want to make a little progression here. When you look at number 1, it says graph y equals 7. What shape do you think this graph takes? Like, what does it look like in general? A line. What else? A dot or a point? Yeah, okay. Like peeking over shoulders. Those are the two things I've seen. I've seen people that have graphed lines of various, shapes and sizes and all that. And I've seen people graph points. So let me start off. Let's talk about the graphing of points. The vast majority of people that I saw that had this graphed put a point right there. Can anyone else identify with that? Maybe you thought about that. Maybe that's what you put. I don't know. Yes? Okay. So what are the coordinates for that point? 0, 7. So let me ask you a question. Why on earth would you choose the x coordinate to be 0? Now, I get why you'd make the y coordinate 7, because it says right there, y equals 7, right? It's fairly obvious. But why would you pick x equals 0? Yeah. Oh.
Because no matter what on the x-axis, it would be along that line.
Well, but I'm specifically talking about that because some people, like when I looked over shoulders, I saw exactly that. Now, some people had lines going on. I get it. But like for those that chose this, why would you only choose 0 for your x? Callie?
Because we don't know what x is.
You know what? We don't know what x is. Completely agree. So why would you pick 0?
Because that's just the origin of everything.
The origin of everything.
Yes,
So that was pretty deep. I'll give you that for sure. So let me ask you this. What if I decided to, maybe I chose that point right there. What if I chose -3, 7? Does that violate this equation?
No. Because you don't know what x is.
Now, I want you to, guys, speaking of going deep, and Callie did just go kind of philosophical on us, I want to go deep here as well. Listen carefully. Listen carefully. If you can get this, I think this will make a lot of sense. Please keep in mind that when you are graphing an equation, all of the points on the graph should make the equation true. Am I right? All of the points should be solutions for the equation. So when I look at -3, 7, and I look back at this equation up here, the only input is a y, right? So if I choose -3, 7, and I plug that into my equation, wouldn't I get 7 equals 7? Is that true?
No.
7 does equal 7. Now, if I chose this point, check this out. What if I chose that point, which is -5, 5, and I plug that back into my equation? Wouldn't I get 5 equals 7? And that's false. So that means that -5, 5 is absolutely not on my graph, right? But -3, 7 sure is, because that made a truth. What if I decided to choose, I don't know, this point over here, 5, 7? Does that create a truth with my equation? So as a matter of fact, wouldn't there be a bunch of other points that would create a truth? As long as the y coordinate is?
7.
So like this one right here, that one right there, all these points that I'm putting on here, don't they all have a y coordinate of 7? So they would all create a truth with the original equation. And of course, all the points in between would have the same characteristic, wouldn't they? What are we talking about? Isn't it a horizontal line?
Whoa.
This is a horizontal line right up there at y equals 7. So earlier somebody said, we don't know what x is. And I totally agree with you. We don't know what x is. The truth is, x could be anything. As long as y is 7, it creates a truth with our equation. Okay? So that's kind of Callie inspired that for sure. That was a little bit of a deeper approach. Can I give you less of a deep approach here? Okay? So this might be a way for you guys to just remember this. This is far from mathematically deep or philosophically deep. But if you look That's just a way to remember it. Oops, I didn't want to do that. If you look at the original equation here, which is y equals 7, if any of you are skiers or snowboarders, especially a snowboarder, you will get this, okay? If the only variable in your linear equation is a y, like literally the variable y, there are no x's, just like this one, then the question I would ask is, why would I ski that? It's a horizontal line. And if you've ever snowboarded, you know
Oh, it's the word.
horizontal, like catwalks and all that, horrible, right? It makes snowboarding no fun, right? Skiing a lot less fun as well, right? So if I see only y by itself and there's no x's in there anywhere, y equals 7 like this, it's a horizontal line, and I'm going to be like, why would I ski it? Stupid, right? No fun. It's cross-country skiing, which is okay, but not as fun as downhill, in my personal opinion. Why would I ski it? It's horizontal. Good? That's just a cutesy way to remember it. The real reason is kind of the thing we talked about. Well, that doesn't make the equation true or not. Anyway. All right, then there's number 2. Now, number 2, I saw some really similar stuff, like you guys suggested earlier, points or lines. So I saw some people that had this. They just had a point right there at -3, 0. And again, I would ask you, why on earth did you pick 0? I understood why you picked -3. X has to be -3. Totally get it. Why would you pick 0? Because it's the origin of things, origin of everything, or whatever she said. But isn't the truth, guys, isn't the truth that if I pick that point right there, which is -3, 3, or maybe this point down here, which is -3, -8, when I look back at that equation, x equals -3, don't they all create truth?
Yeah.
If I picked this point over here, if I pick that point over there, which is 7, 7, do you see how that creates a false?
Yeah.
7 does not equal -3, so that's definitely not a solution to my equation. Would you guys agree that anything in this pattern has an x-coordinate of -3? Therefore, creates a truth with the original equation. What are we looking at here? A vertical line, yeah.
With arrows.
So there's my vertical line. We always put arrows on the end of it. Get this nice vertical line. So the deeper math thing to think about here is those points all make the original equation true. That's why you get that graph. Fair enough? You want to hear the cutesy skiway? Okay, so remember, the one on top there, if it's simply a y and there's no x's, you would say, why would I ski that? No fun. Now this one, if there's only x's and there's no y's, if you tried to ski that, you would get x'd out. Right? If you tried to ski a slope like that, you would be x'd out. You would not exist anymore. You'd die, right? I mean, you're skiing off a cliff. Unless you have a parachute, yeah, you'd be x'd out, right?
Your eyes.
Depends. I've skied off a few cliffs in my day. And it depends on the landing, depends on how high the cliff is, all that good stuff. I get it. But let's say it's really tall, you're going to get x'd out. Fair enough? Is that a cutesy enough way for you guys to remember it? There's other ways. But anyway. Okay, fantastic. So I got one last thing to show you before I turn you guys loose on some practice questions. This will be an excellent review of yesterday. Here we go. This should look really familiar except for one symbol. What's the one symbol that's a little weird? Yeah, the alligator mouth, right? The greater than on this one. And so we are going to deal with that. But again, I want to emphasize to you guys a couple things. Number 1, remember that the graphs of these equations represent all of the ordered pairs, all of the points that make the original equation true. Okay? And then the other thing is this. What are the 2 things that you have to graph the equation of any line? A point and a slope. Not a y-intercept in a slope. I mean, that's true. That's a little too specific, though. You don't have to have the y-intercept. You just need to have a point that's on the line and the slope. And if you have those 2 things, you can graph the line. Now, this equation is in a special form. What form is this in? It is in slope-intercept form, and I'm going to write that right above here. It's y equals mx plus b. And I think if we write, things right above each other that kind of go together, we can figure out what is what. So I'm going off to the side here, I'm going to put my point and my slope. So let's start off with the slope. What would you guys say the slope is for this line?
1/2.
It's 1 over 2, yep. And if you guys remember from yesterday, slope is something over something.
Rise over run.
Rise over run, or change in y over change in x, yep. So there's my rise, there's my run. Now my point. Remember, a point is always going to be something, comma, something, x, comma, y. So what would you guys say the point?
0, -3.
0, -3,
Because it's your y-intercept.
because it's the y-intercept, right? The y-intercept is always going to be 0, comma, whatever. In this case, -3. So when I start graphing a line like this, I'm gonna feel bad for you if you guys are racing ahead of me, because because of the greater than, there's a little twist to this. So please don't race ahead of me here. Am I going to graph the point before the slope or the slope before the point? You always graph the point first, always. So 0, -3 is right about there. And if you guys remember from yesterday, I asked you to illustrate your slope. My slope then is rise 1, run 2. So here's my rise 1. There's my run 2. And so there's a point. That's a point. And rise 1, run 2. You guys okay with reversing this? What would create the same pattern? Instead of rise 1, or like up 1, right 2, I could go
Down 1, left 2.
down 1, left 2. Yep, that's the exact same pattern. So down 1, left 2. Okay. You guys starting to see this line take shape? Okay. So here is where this gets a little bit different, and it's because of this inequality. So again, I want to remind you guys of something. When you graph anything, whether it's a line or a point, you guys remember those number lines we did with like open circle with an arrow going to the right or the left or whatever? Whenever you graph something, what you're trying to do is you're trying to represent all the solutions for this equation. And this inequality here is going to change things up a little bit. Here's the first thing I need to do. Maybe you guys have seen this before. Is I need to notice that this inequality is greater than, and we need to notice that it's not greater than or equal to. It doesn't have that extra little line down there. And so because it does not have the or equal to on there, the line that we draw here has to be a dotted line. We're going to talk about what that means here in a second. But literally it's going to be, I'll sketch it out here real quick. What it needs to look like literally, a dotted line. Do you see how it's dotted, right? It's got little dashes or a dashed line. We would still put arrows on the end of it because it does continue on forever and ever and ever. But because it is simply greater than and not greater than or equal to, it's got to be a dashed or a dotted line. If the or equal to is there, it would have to be a solid line. Okay? So there's an easy way to remember that. If the or equal to is there, like if it was like this, then it creates a solid line, right? If it's not there, there's going to be little gaps in your line creating a dotted line. What that means is this. Do you guys remember when I'll erase this here. Do you guys remember when we graphed those number line graphs and we had like 7, we had an open circle and then an arrow to the right or something like that? The dotted line is kind of like the open circle. Remember, the open circle means that it goes right up to that number, but it doesn't include that number. What this dotted line means is we go right up to the line, but we don't include the line. Okay? So I'm curious, you guys might know this. Does that dotted line represent all of the numbers that make my original equation true?
No.
There are a lot more, aren't there? Have you guys ever done shading on a line like this? So those of you who haven't, you're going to do a little bit of artwork here. We're going to do some shading. Let me give you an example. What this line has essentially done, let me continue it over here just a little bit. Something like this. This line has taken my graph, and it's essentially split it into 2 regions. I'm going to call this whole region up here region A, and this whole region down here region B. That make sense? There's one kind of upper left, and there's one that's kind of lower right. And all of my answers, all of my solutions are going to be either in region A or going to be in region B. It's one of the two. It's not going to be both. So I'm kind of curious, does anybody have a thought as to how you could figure out whether we're going to use region A or region B?
Is A if it's
No. The not equal to is what creates the dotted line versus solid line. Got to do something a little bit different. What do you think, Josh?
I was gonna say that A is for greater than.
Depending on how you write it, we could actually reverse that, right?
Oh, yeah.
So you want to be really careful. I think there's a more consistent way. Your idea would work here, but I think there's a more consistent way. What do you think, Ben?
I always remember it as if it's greater than it goes up, it's less.
Well, that's kind of the same thing that Josh said. And again, like if I write it the other way, then the rule gets reversed, and that makes me nervous.
Yeah.
Like if I write the y on the right side instead of the left side, the rule is backwards. I don't like that. I'd rather have something that works no matter how the equation or inequality is written. Noelle, you had an idea or no? Or are you going to say the same thing as?
I was gonna say if it's greater than y, it's shaded where, like, above the number.
And that's essentially what the other, our gentlemen here were saying, kind of the same thing. And in this case, I will say that'll work. But if the inequality was written backwards, then it's exactly the opposite of what you're saying, which you can see would make me nervous, right? I want you to be able to be consistent. Ava, any thoughts?
I think what, like, she might have trying to say is that if it's open towards the y and everything, like whatever is exactly facing the y, no matter which way it's written.
Oh, man, you got to be careful with that. I can think of plenty of examples where people use that line of thinking and got it exactly wrong. They did the opposite. Can I get maybe any other thoughts? There's like one way that'll always work. Here's what it is. Do a little test. See what happens. Here's what I would say. If this really is region A up here, and this really is region B, I'm going to test one of the two of them, and I'm going to pick the easiest conceivable test point I can think of. What do you think that would be? 0, 0. So here's what I'm going to do. I'm going to come over here, and I'm going to test 0, 0. I'm going to test that in my original inequality. So I'm going to test it back up in here. Here's what it would look like. I'm going to plug a 0 in for y and a 0 in for x and just see what happens. So what is 1/2 times 0? And what's 0 minus 3? Did I create a truth? Is 0 greater than negative 3?
Yes.
Yeah, it totally is. So since 0, 0 created a truth, that means all of my solutions are up there in region A. And so the answer is definitely not region B. And so the way that I would note this as my answer is I shade. I'm going to come up here in region A, and I'm going to shade all that. So here's what that means. If I pick any point in that orange shaded region, and I plug it into my inequality, it will create a truth. They all work. They're all solutions up there. So you could pick any of them. You could say, you know what? Today I want to pick 1,6, which is right about there. It would work. It would create a truth. But maybe the next day you want to try out -5,9. That would also create a truth. So any point within that shaded region would be okay. It would create a solution for the original equation. So how many solutions are there to the inequality like this?
a lot.
Yeah, infinitely many. Infinitely many. In fact, just to maybe draw a little parallel, do you guys remember doing stuff like this where you had like open circle on 5, arrow to the left? How many answers were there in that graph? Infinitely many, right? Because how far could that arrow go? It just keeps going and going and going. So that shaded region just keeps going and going and going. All the points within that are solutions. Okay? All right, so you guys have a couple of practice questions, and I'm hoping that they'll go really, really well. They are on the next couple of pages here. Number 1, graph and label. So on this one, I want you to actually label the lines because I want to make sure that you know which one is which. And then number 2 is quite similar to the one we just did. Number 3, a little bit different. So let's see here. We've got about 12, 13 minutes. I want you guys to work through as many of the 1, 2, and 3 as you possibly can. Question, Callie?
So on one's the 2 different lines?
Yep, 2 different lines. Yep. Two different lines. Question, Chase? Looked like you had a question. Am I wrong?
Oh, yeah. So,
Next period or next class, we can do that. So for number 1, did you guys get a horizontal line? So I'm hoping for A, you got something like this. Oh, I missed. Let me try that again.
So close.
Did you get that?
Yeah.
Put arrows on the end of it.
A to label.
And y equals -5, or you could call it line A or something.
Would that works?
You guys good?
Just
Sure. Yeah, because I called it A, so that's fine. Okay, and then, of course, the other line, if you tried to ski it, you'd get X'd out, right? So that's x equals 7. So that's roughly right there. And put arrows on the end of it, and that would be x equals 7, or you could call that line B. So please take a look at what you have for yours. Look at what I have for mine. Do you have any questions? Okay. So then, please take a look at number 2. By the way, with number 2, the whole ski thing still holds. Because do you see how number 2 doesn't just have a y? And it doesn't just have an x? It's got both, doesn't it? So the only slopes you'd ever really want to ski would probably be the ones that have a y and an x. Because it's going to be some kind of an angled slope. Fair enough? Okay. So with this one, is this equation or this inequality right here, is it in slope-intercept form right now, or is it in point-slope form?
Slope-intercept.
It's slope-intercept, I agree. So we're going to write y equals mx plus b, and we can identify the important pieces of information. And walking around, there's occasion for sure to talk about this. I want to make sure that you guys are solid with this. I need to get the point off this, and I need to get the slope off of this form. What is the point? Always guys, here's something really crucial for you. Walking around, I saw some folks that just wrote, my point is 5, right? There is no such thing as a point that's just at 5. It's always going to be x comma y, and this point would be what? 0 comma 5. There you go, because it is the y-intercept. So 0 comma 5, and the slope for us would be?
-1.
And that means my rise is -1 and my run is 4.
Oh, yes, I did.
Okay, so I plot the point first. The point is 0, 5. 0, 5 is right about there. And then my rise, what does a rise of -1 mean? Down 1. Yeah, so we're going to go down 1 and then right 4. So down 1, right 4. So there's a point right there. And then down 1, right 1, 2, 3, 4. So there's another point there. I could reverse this. So instead of going down 1, right 4, I could go
Up 1, left.
up 1, left 4. Yeah. So up 1, left 4 would be there. That's plenty of points right there. So you can start to see this line taking shape. So I'm going to try to connect these with as straight of a line as I can. I'll put arrows on the end. Should I leave this line solid, or should I turn it into one of those dotted lines? Why dotted?
Because it's not.
That's right. It doesn't have the or equal to, so I'll go through and try to turn this into a dotted line. Something like that. There we go. And then the last thing I got to do is decide about my shading. I am a fan of using a test point here. What would be the easiest test point for this line? 0, 0. That's, unless it goes through 0, 0, that's always going to be your best test point. So I'm going to test out 0, comma 0. So that would give me 0 is less than -1/4 times 0 plus 5. What's -1/4 times 0?
0.
And of course, 0 plus 5 is 5. The most important thing here, is that really true? Is 0 less than 5?
Yes.
It totally is. So we say true. That means that 0, 0 is a part of my answer set. So I'd be shading down here.
If it's not true, would you just shade above or should you test the point above?
So if it's not true, that means it really has to be the other region, but if you wanted to double check and make sure you didn't mess something up, you could always do a test value up there as well.
All right.
Yep, good question.
All right.
Yeah, as long as you didn't mess up, if it's not this one, then it's the other one.
Yeah.
All right, guys, great job. See you tomorrow. We'll do your DMR quiz first. We'll continue on with graphing lines and inequalities. Have a great day.